Have you ever wondered how we can use ChatGPT or other GenAI tools to hack systems, whether it's ICS or OT, or if we just talk about control systems in general, or different IT systems? And that's what we're going to be talking about in this video. Of course, real quickly, a quick point. We're talking about using ChatGPT and other Gen AI tools to break into different types of systems, especially in control systems and in ICS and OT. We're talking about breaking into systems that control physical processes in the world. And these can lead to potential physical and environmental dangers. So the point of this presentation is for awareness and to get the information out for all of the cybersecurity defenders out there, no matter if you work in ICS and OT or IT, because the attackers are already doing these things. But there's a lack of awareness on our side, on the defender side. And so that's why I'm sharing this presentation. Now here's the agenda, and we're just going to jump right into it. And I like to start with a story. This goes back 10 plus years when I was really just getting into my first real world ICS OT cybersecurity project. This is for a very large environment, and I met this gentleman who runs the cybersecurity program for a very, very large company. And we were having a conversation almost at break or lunch one day about PLCs. And he mentioned that, oh, well, it's a PLC, so it's not vulnerable to different attacks like buffer overflows like a normal, like a Windows system would be. I was like, what do you mean? it's it's hardware, it's software, it runs code. Of course it's vulnerable to those things. And of course, based off of his experience, his position, I was still fairly new to the field, and I started doubting myself. I was like, "Ooh, what? Maybe there's something there potentially." And then, of course, I was like, "No," and then grab my phone and look up, and it's like, here's all these advisories, the vulnerability advisories released by CISA, specifically for PLCs, programmable logic controllers, which are the most commonly used type of ICS OT asset today. And so to me, it really spoke to if you had this person that runs this huge program that and doesn't understand that these systems are vulnerable, then what are the rest of us mere mortals expected to do? And that really stuck with me. And that there still is a lot of missing awareness around the security of these PLCs and other control systems. And part of it is with the PLCs themselves, part of it's with the protocols that they use, like Modbus, which is unauthenticated. And we're going to look at how we can take advantage of that in this presentation, just like state adversaries do. So when you look at trying to get awareness out there, well, I was doing my thesis for SANS for my master's degree, and wanted to write the thesis so it could help spread awareness, right? Help educate others on how vulnerable PLCs are. And for some of you that are familiar with some of the SANS folks, Dr. Johannes Ulrich, who also runs the SANS Internet Storm Center, he was my thesis advisor. So we went back and forth about different topics. My first topic, pretty much, he said, yeah, there's a 500-page book you need to write. That's not what we're trying to do with your thesis or this basically SANS white paper to finish your master's degree. So we went back and forth. And I came up with this idea that, okay, PLCs, part of the security, we talk about PLCs and other controllers in general. And this came up with the Trisis Trident incident when a state adversary had targeted a petrochemical facility in the Middle East. And they had taken complete control over the entire network, including the DCS, which is kind of like a PLC on super steroids if you're not familiar. So it's kind of just for now, right, at a high level. And so they had full control over this DCS, or distributed control system. And what they were going to do was potentially cause an explosion in the plant to not only damage the plant and the environment, but kill somebody. Rob Lee over at Dragos always stresses that. That was their intent, was to kill somebody. And so out of one of the lessons learned out of Trident or Trisis was this idea that controllers and other PLCs and other controllers have what they call basically a run switch. And so these different controllers have different modes that you can put them in. Most controllers at least have two modes. Well, I should say all controllers have at least two modes. One's called run mode, and then one is stop mode or something similar. So let's say we have a PLC like the ones from Click Automation. It has a stop mode. So the idea is it would be stopped if you're making program changes or upgrading the firmware. And then if you were to run it in production when you weren't making any changes, you would put it into run mode. And a lot of people think, and some different types of controllers, if you put them in run mode, it is like this idea of putting it into read only. So it can't be remotely manipulated, which from a cybersecurity perspective is great. Because at that point we can say, oh, well, if we're not manipulating it remotely, then it can't be attacked unless somebody is physically on site, in the local network or physically connected to that controller. So people see it as a security mechanism or control, which is great. The problem is that when you put a controller in run mode, that's not always the case. So I had 5, 6 different PLCs that I had used as part of my testing in my thesis. I talk about 2 in the paper, but I had 6. And each one, even if it was in their equivalent of run mode, that you would go to make a change to the programming on the controller to change its logic, and it would say, hey, you're in run mode, and normally you shouldn't make changes to the running code, but if you want to, just say yes and we'll make the changes. So having it in run mode didn't prevent any of those changes from actually being made. Now, all of those that I had worked with, you couldn't upload firmware, which is also a big concern. So an attacker couldn't upload malicious firmware if it's in run mode. Which, great, right? At that point, then we can look at, okay, we still want to keep the controllers in PLC. It's not as secure as everybody makes it out to be, but at least an attacker couldn't upload malicious firmware at the least, right? Great. So it's a big win. So out of that Trisis incident, a lot of vendors and security pros talked about, well, if we can monitor our different controllers and PLCs in the field to see if they're in run mode or not, we could tell if they're kind of in this more secure state or not. We want to make sure all of our controllers are in run mode unless maintenance is actually being done. And maintenance is done every 6 months, a year, or 2 years on these types of assets. So after all of this, my thesis came down to, I'm going to build a tool, a web page essentially, that will allow operators to monitor all of the controllers in their environment, or at least the types of controllers I was testing with in the thesis, to see whether they're in run mode or not. And I don't. Some controllers have like eight modes, and I don't care if they're in any of those other modes. I just want to know, is a controller in run mode or not? If it's not in run mode, then it's this idea that it's at a higher level of risk, right? It's more vulnerable than when it's not. So working with Dr. Johannes Ulrich, like, I'm going to create this tool that's going to monitor PLCs to determine if they're in run mode or not. He's like, that sounds awesome. Go with it. And I thought, okay, great. I have my thesis. And then I realized, oh my gosh. Like, first I have to figure out, with these PLCs, can I determine remotely if they're in run mode or not? fortunately for me, and we'll see an example that it turned out to be very, very, very easy. So I, was concerned, but uh, didn't have to be. And then the other thing was I was like, wait a minute, I have to create this web page to do all these checks and to add controllers, and all the pieces started going through my head. I'm like, I'm not a developer. I hate developing code. That's why I don't have the patience. And then I realized, wait a minute, I was just, reading about attackers, or we had been reading, for at least 6 months, if not a year, about attackers using ChatGPT and other Gen AI tools to write phishing platforms. Well, if they can use ChatGPT to write phishing platforms, why can't I use ChatGPT to work on my thesis? And so this is what it ended up becoming. So this is a sample part of a web page that you would see. Right? And you can see that it has a list of, and this is just all sample data to give you an idea. We can have, here's 10 different PLCs we're tracking. We can see the vendor, we can see the model, we can see the firmware version. So we could use that for things like vulnerability management. We can see where it's located within the plant environment. We can see the IP address, the MAC address, and lastly, we see, is it in run mode or not? Because remember, the idea is if it's in run mode, we can't do things like, or attackers can't do things like remotely upgrade the firmware, right, and build in, upload malicious firmware to that asset where they could have control over it. But if a controller goes out of run mode, I want to get a note that says, ooh, we're no longer in run mode, you need to investigate. Now, maybe this is somebody doing maintenance, right? Maybe this is scheduled, maybe it wasn't, right? And they're still doing maintenance. But we do the investigation, and 99.99% of the time, it's not malicious, it's not an attacker in the environment. It's somebody doing work, whether, again, it's authorized or not. So we do our investigation, and we can click on the little resolve button, and life goes back to normal. So the whole point is I'm not a developer, right? And this is a cool little web page. Gives you a little alert. There's even a login, and there's a place to go in and like change your credentials and add new controller types. But I just really I used ChatGPT in about maybe 30 minutes, maybe an hour tops, to write that website without using ChatGPT ever before that, other than, to ask it a couple stupid questions. So then I got to thinking, well, this is great. I finished my thesis. And then it made me think, well, I always think of like all these great little tools. At least I think they're great, right? Little tools that'll help me do my job, or I'll find interesting, and I can use them maybe even just for awareness, and share with people to highlight a security issue. Why couldn't I use ChatGPT to write those tools? And then I also look at, well, not only from a defensive perspective, but what about from that offensive perspective when we talk about hacking into control systems? And so that's where we get into using ChatGPT. And you don't have to have a paid for account to use ChatGPT to do any of this, which is great. Eventually it times out, and it'll say you'll have to wait, an hour or two before you can use it more. But at the same time, you can just use a free account. You don't have to pay. You don't even have to log in. And so I always start, any development class you take always starts with this idea of printing hello world on the screen, right? It's the most basic form of development that everybody does, is that first step. Now I take a little slightly different tactic, and I use hello friend, because that comes from, if anybody watched Mr. Robot, right? The first episode of Mr. Robot, it's the first thing that Elliot says. It's the title of the episode, believe it or not, and it's their play off of Hello World. but instead hello friend, and how he's talking with, you know, whether it's the voices in his head or is it you, the audience. But anyways, before I digress too far. So we're going to use ChatGPT to go ahead and just write hello friend to the screen. And then we'll jump into some other projects and we'll kind of build off of that little by little. Okay, so you can see I went ahead and pasted in the prompt, write a Python script that will print hello friend on the screen, and I submit that. And you can see that ChatGPT just starts spitting out. And it does a couple of cool things, right? It says, hey, I understand what you're asking for. Here's the script. Here's a button that you can click copy. So that way we can go ahead and paste it into our script to run. And then it even starts to explain, right, how to run the script and essentially what it does, which is great. So what we can do is we can open up, I just open up, you know, Notepad and oops, guess I didn't click the button. All right, so we copy the script into the clipboard. We put it into Notepad. Maybe I did have it. Maybe I didn't. So we're going to go ahead and save it on my C drive. And you can see I'm doing this on a Windows machine because I actually use mostly Windows in ICS OT environments. So most of my scripts that I write for ICS OT typically start on Windows and then migrate over to Linux, like if you have a Kali distribution. But anyways, so I'm going to go ahead and change this, and we're just going to go, you know, hello friend dot py. Right? So I can go ahead and close that out. I'm going to open up a command prompt, change to the script directory, and run the hello friend script that ChatGPT wrote for us. And you can see it does its job. Hello friend. Dot dot dot. Great, right? So we have the ability to ask ChatGPT to write a script for us to do something, save that out, run it, and it does what we asked it to. Awesome. So we can build from there, and we'll build pretty quickly. And I did want to mention real quickly that the nice thing is that I have all these prompts documented in my GitHub repository. So if you go into the GitHub repository for utilsec and then go to the ChatGPT repository, it's this upper left one. So not, it's for some reason not the most popular repository there, but you can go in there and you can see there's a lab manual that walks you through almost all of the steps that we're talking about in this presentation. Right. And so you can just copy and paste. It even walks you through the idea of how to install Python on your machine, et cetera, et cetera. And when I do the presentation, you can see that I have the slide decks that walk the audience through the process that we're walking through. And of course, there's our hello friend. All right, so in this next part, we're going to take it up a notch. We're going to go from creating that basic Python script to print hello friend to creating a port scanner. Just for testing purposes, it's not meant to replace Nmap in any stretch of the imagination, right? But you can see we're going to create a simple port scanner for ICS or OT environments, or you can use an IT. You see, we're going to test for 5 ports. We're going to test for TCP 80 and 443, which are used for websites, right? 80 for unencrypted HTTP and 443 for encrypted HTTPS, because we do see a lot of assets now in OT environments that run websites and web applications, and each of those can have their own vulnerabilities. So we want to be looking for them. And then the last 3 are related to OT protocols and versions that run over TCP/IP. So 102 is associated with Siemens's S7. 502 is associated with Modbus, which we're going to be talking a lot more about in this video. And we're also talking about Ethernet IP, which runs on TCP 44818. So we're going to look at those. So like earlier, I am going to go ahead and copy that text from the lab uh, manual and just post it into ChatGPT and let it run. And you can see it goes through, gets us our script. I'm going to go ahead and copy that. We're just going to assume it works. I'm going to go ahead and put it in the folder. I actually had a earlier script, so I'm just going to edit that. Get rid of that. Oops. Or just so you can see it. Get rid of the previous script, input the new script, and save that out as scanner.py. So now, when I open up the command prompt, I'm going to go ahead and I'm trying to run Nmap already. So what we're going to do is we're going to change to the scripts directory again. I'm going to go ahead and run Python and then scanner.py. And you can see it's going to ask me for an IP address. So at first, I'm going to go ahead and give it the IP address of my home Wi-Fi router. So you can see what it looks like scanning a typical, kind of IT asset. And there you can see, hey, we tested these 5 ports, 80, 102, 502, 448, 18. We're closed, but ooh, there's something on 443, right? So we know that there's a port open on 443, and more than likely there's a website sitting on HTTPS there. Okay, great, right? So we have a fully functional port scanner. Well, now we also wanted to talk about how we can use this in control system environments. Now, we typically don't do active port scanning in control system environments, but that's not necessarily something that attackers always believe in. And so if we run this, and this is, again, just running it against a lab system. So I'm going to go ahead and scan 192.168.100.200. This is a PLC that I have on my lab network. And now you can see, oh, we have port 502 is open, right? 502, remember, is used for Modbus over TCP, which is the most commonly used OT protocol we see. So Modbus is everywhere. Some people talk about it as the cockroach of OT protocols because it's everywhere. I don't think it's that bad. It does definitely have its own security considerations, like all other OT protocols, and we'll actually see some of those as we go throughout this video. So, but now you can see we have a perfectly working little kind of port scanner for ICS, OT, and IT, right? Just scanning those 5 ports, and you can add as much functionality as you want. So let's jump back to the slides, right? So we created our script, we ran our port scanner, we found the open website on the home Wi-Fi router, we found Modbus running on the PLC, great, right? That's where we're at. So where do we want to take it next? So many of you have probably heard about living off the land, right? How attackers and pen testers, right, use built-in capabilities in systems to meet their objectives, to do what they do. Right? Meaning, let's say, yes, it's great, I have this Python script that I wrote in ChatGPT as a port scanner, but if I wanted to use that in a target environment, if I copied that script just onto a Windows machine, right, then I would have to install Python on that Windows machine to allow it to run. That could potentially tip off the defenders that I'm there. Right? We want to use what's built into the system. So in Windows environments, what we can do instead of using Python to run our scripts, we can look at scripting languages like PowerShell. Right? PowerShell was created to give admins the ability to control every aspect of the Windows network. That sounds like something that the attackers would want. And it's something we can take advantage of here. And the nice thing is we can use ChatGPT to go ahead and create that script for us. And you see, all we have to do is we'll jump back to ChatGPT, and I'll just type in. I haven't copied it over, but we'll just say, convert the previous Python script to PowerShell. Give it a sec. here it comes, right? Here's our answer. And now we have almost completed, right? Our PowerShell script. So I'm going to go ahead and copy that. Let's go back to our folder so we can create a new script. We're just going to call it scanner. I'm going to go ahead and add the code. I'm going to go ahead and save it. And let's go ahead and open up. Go ahead and take our previous prompt. Let's clear that screen. I'm going to go ahead and bring up PowerShell. And then I'm going to run that scanner script. Now what you can see is I went to run the script and I got an error message. Like, that's never fun. And this is one of the reasons why I'm not a developer, right? If I see something like that, so I just I'm done. I just don't have the patience to troubleshoot. But the really cool thing with ChatGPT is we can just copy this error message, paste the error message back into ChatGPT as a new prompt, and then ChatGPT will say, "Oh, hey, thanks for giving me the error message. I see the problem. You have an issue with your previous script. So when it got converted from Python to PowerShell, there was an issue it wasn't aware of. I see what the problem is now, and I'll fix it. And here's the fixed script." So we can go ahead and now take the fixed script. Now let's go ahead and plug that in to the file. And make sure I save it appropriately. So get rid of that. We'll go back to our screen. We can go ahead and clear it out. We'll run it again. And now, oh, it's running. Just like the earlier one we had in Python, where, okay, yeah, let me go ahead and type in the IP address of that PLC. And then, oops, we get another error message. Let's just try for the sake of time. Let's add, nope, it's going through the same thing. So we're in some type of deadly loop. So let's try and fix it again. So ChatGPT thinks it's fixed the problem, hopefully this time. I've got stuck in a couple of loops like this before. All right, let's go ahead and update our script one more time. Let's exit out of that. We're going to rerun it. We're going to give it an IP address of the PLC to scan, and it looks like now finally it's working. So I never actually had ChatGPT fail twice in a row on doing that exercise. I've definitely got stuck in that loop for like 9 or 10 times sometimes, but I've always had it figure out the problem eventually. And here you can see now, again, this is our PowerShell version of the scanner script that we're running against the PLC to see, oh yeah, Modbus is open. If I see Modbus open, I can almost say, yeah, that's probably a PLC. And we're not running Python now. We didn't have to install Python on this machine to allow it to run, if you want, an attack tool or a defensive tool, right? Board scanners are used for both. The idea that it's living off the land. We're not installing anything additional on the host to run that PowerShell script. And ChatGPT allowed us to do that, right? It took that Python script, converted to PowerShell, made a mistake. It fixed that, still had a mistake, and it fixed that, and then we have a running script. So if you get anything out of this video, you can use ChatGPT to troubleshoot your code, which is amazing. Because now I'm not as, I guess, really intimidated about writing code. Not that I'm writing it, right? But using ChatGPT to come up with things and doing the troubleshoot. And honestly, I've actually learned a lot about coding and writing code and even troubleshooting code by going through and using ChatGPT to do these types of exercises. So let's jump back to the slides. And this is what we were just looking for, right? We get an error when we try to run that PowerShell version the first time. And so we can take that error message, feed it back to ChatGPT, and it fixes the issue for us. And usually that's the only time you have to do it. And here's the example that I used during the presentation. So where do we go from here? And this is what I really like, and I think I touched on this earlier, because a lot of times I think of, oh, it'd be cool to have a tool to do this. Oh, it'd be cool to have a tool to do this. Again, I'm not a developer. I don't even have the time. If I was to write something, even probably like that basic port scanner, it would take me days, if not weeks, and I just don't have that time. Like everybody's busy, right? We're doing our jobs. So now we have ChatGPT though as a tool to help us. Hey, if we think of something, we can build it. Like I mentioned at the very beginning, if an attacker can use ChatGPT to create a fully functioning phishing attack platform, why can't we use it to do fully functioning programs? And that's why I did for the thesis as well. So here's some examples that we're going to walk through that are relevant mostly to the control system world, right? If you're a defender, in control system environments, we always talk about a lack of asset registers. An asset register is just a fancy way of saying asset inventory. Right? In an OT environment, we want a list of all the IP addresses that are active. We want to understand what types of assets are connected to those IP addresses, right? Is it a PLC or some other type of controller? Right? Or maybe it's an engineering workstation, which is just a Windows laptop or workstation usually. Or is it maybe a data historian, which is usually just a Windows server running Microsoft SQL Server? But we have to understand what we have in the environment to be able to protect against it. OT environments, though, are notorious for not having asset registers, or if they have an asset register, it is far from complete. I always talk about it being like Sudoku, where you get the puzzle with a couple of numbers, and it's your job to fill in the blanks. That's very much like building an asset register. So in this case, what we're talking about doing now is using ChatGPT to create a tool to say, hey, I want to create a Python script to read a PCAP, a packet capture we take from sniffing the network. Take that and go through it, find all the IP addresses of the assets that are communicating, take the MAC addresses for those IP addresses, and then map those out to the appropriate vendor, because you can take the first half of a MAC address and look it up in an IEEE MAC database. I like the version that the Wireshark team makes available on their website. And tell me who the vendor is. And just for the sake of time, we're just going to go through some of these examples and use the slides. I think you get the idea of using ChatGPT and saving out the scripts and running the scripts. But you can see, in this case, we're going to run our prompt that we feed it. We're going to come out with this tool called parser.py, this Python script. Now in this case, though, the first thing I see is enter the path to the PCAP file, which we have a couple of packet capture files with OT traffic. Of course, when I saw this, and I was like, well, I'm on a Windows machine. I don't really want to type in like C:\\, I don't like downloads, packet captures, I mean, it just gets really ugly. I'm much quicker on Linux hosts doing those types of things. So in this case, since I'm on a Windows box, I went back to ChatGPT and said, hey, you know what? Add a graphical interface. I had no clue if this was going to work. But add a graphical interface to the Python script so I can specify the file to load. I saved it out, and when I ran it, this is what I got. Like, boom. As soon as you run that Python script, it asks you, well, where do you want to pull the file from, the packet capture that you want us to read and interpret or parse? So you can see here we pick any of our packet capture files and it'll go through, it'll parse out the IP address, the MAC address, and again, it maps the MAC address using the first half to the associated vendor. So we can see, oh, there's some Siemens devices on the network. There's a Mox attack. And there's some Apple devices that might or might not supposed to be there. But the nice thing is, if you don't have an asset register, a lot of times environments do have packet captures, believe it or not. And so it's a way to start that asset register, and then you can go back and track down these machines to see, or these assets to see what exactly they are, right? Is it a PLC, right? Is it what model, what firmware version does it run, right? All that important information that we need to do things like vulnerability management and incident detection response in control system networks. Now, another interesting kind of road I went down was how to find different PLCs on the internet. And not necessarily using ChatGPT to do that, but what could we do with those PLCs once we find them? But also keeping in mind that these devices are exposed and they're connected to processes that we don't want to impact or interfere with. So this is another one of those that was more of a research project. Right? And so the NSA, they released what they called their Elite Wolf project. And I was really excited when this came out, because it wasn't, I don't know, a couple of years since the NSA had released Ghidra, right? Their program reverser that you could use to do things like write buffer overflows, right? Really exciting stuff. So I was like, ooh, the NSA is releasing something on GitHub. I'm like, oh, this has got to be really cool. And then I looked at it and I was like, this is kind of lame. I mean, it's very, at least very, very disappointing. Because what Elite Wolf was it was a collection of basically three different text files, and each of those text files had snort intrusion detection system rules, or IDS rules, to detect certain activity. And the one I found the most interesting was the one for the Allen Bradley Rockwell PLCs. And you can see it's basically that there's different rules, and you don't see all of it here, but the rules would go through and would trigger if somebody visited a website connected to a PLC. Now, most PLCs aren't connected to the internet; they're all internal, and so could this potentially detect if an attacker is in your environment and they hit the website on the PLC? Sure, it could, or it could be a technician hitting that web page as well. So are these the greatest signatures? Probably not. Could they help? Sure, kind of. But it could also generate just a lot of the false positives as well. So your mileage will vary, right, depending on how you, and when and where you use the rules. But the one thing I was thinking of is like, well, they do have, if I'm looking at this part of the rule, it's a URL. Right? It's the URL of the web page, one of the web pages on the controller on the PLC. So it was like, oh, well, I wonder if any of these are exposed on the internet. So we just take that, use it as a search string, and then you can come back and you can say, yeah, there are a few of these on the internet. There's about 50. I think still, if you run the search today, there's about 50 on the internet. And the interesting thing, right, is that these are PLCs that are connected or exposed to the internet. And you can see there's one PLC, there's another PLC, there's another one. And you only see three, part of the IP address on the title line, but you can see the complete IP address and the URL there. You can see, yeah, these are web pages exposed to the internet. So they're PLCs. And I did look it up based off of the vendor information you find on the website to see, well, what am I really looking at? Because I like to understand what type of asset this is and what does it look like in the real world. It just makes me feel more connected to it. And here's a picture of the Allen Bradley PLC. And Allen Bradley got bought by Rockwell a long time ago. So that's why you see a lot of it's Allen Bradley or it's Rockwell or it's both, right? Just to alleviate any confusion that might might be there. So we can find these PLCs connected to the internet, which is really interesting. And this is one of my most interesting, at least I think, probably the most interesting page on these PLCs. Because if you connect to them, it's basically showing you netstat running on that controller. As you can see the connections, you can see, who was just connected. You can see who's currently connected. You can see the local address. So we can see the internal IP address of the PLC, which is never good. If somebody can see your internal IP address, is an attacker really going to use it against you to take over the environment? No, it's not a big deal. But just that you're exposing your internal IP addresses on the internet, that's not a good sign, right? There is a basic issue at play that you need to fix. And in this case, it's your PLC being exposed to the internet. You can see what port on the PLC they're connected to, or the PLC is connecting from. So you can actually see, oh yeah, people are connecting to it on the web service, port 80, the HTTP page. They're also hitting Ethernet IP, or you can see the PLC is also going out and communicating over Ethernet IP. It's actually communicating to other public IP addresses on the internet over Ethernet IP, which also makes you start to wonder, right? So we can see, again, the internal IP address of the PLC. We can see the ports that are being connected to, connected from and to, right? We can see the remote addresses, right? These all look like public IP addresses. So we see some internal IP addresses as well, like 10.25.10.41, which is not the IP address of this controller. So we know on that internal network, there's another host that it can connect to. And it's communicating over Ethernet IP. And then we see all of these other IP addresses as well. There's a lot of interesting traffic. I mean, just the fact that, right, the PLC should not be exposed to the internet, period, the end. But it is, and then we see all of this other traffic communicating with the PLC, including myself, right, because I'm connected. So this is where I got a little bit more curious. So I was like, well, I can use ChatGPT to write like a really simple web scraper to connect to this PLC. And I'm not going to run it long, but the thing is exposed to the internet and it's getting pounded all day long. And so hopefully whatever process on the other side of that PLC is safe and safe at least. So I'm going to use ChatGPT to create this scraper. It's going to hit the web page, take off all of the public IP addresses, or actually all of the IP addresses, and then it'll just determine, which is private, which is public. And then if it's a public IP address, it'll do a GeoIP lookup based off of that IP address to tell us where in the world is this connection coming from. And so you can see that when I first run it, it goes and says, oh, you have a connection from Seoul in Korea, right? One from Philadelphia, one from New Jersey, one from Wisconsin. Now there's private IP communication going right on with that PLC. That's where we saw there was another host internally communicating with it. There's connection from Simpsonville, South Carolina. That's me. And then there's these other connections from multiple different IP addresses, public IP addresses in Wisconsin. And we won't go further down that route. And then you can just keep running that script if you want to see where new connections coming from. And only let it run for like a couple rounds, because again, I don't want to impact any process. And you see, additional, just a few minutes we saw Amsterdam comes in, China comes in, Germany comes in addition to those others, in just a few minutes. And so the idea is that we have these assets that are exposed to the internet. They shouldn't be, but they are. That's one of the reasons why I teach the OSINT for ICS OT course. So let's find these assets that are connected and exposed to the internet and get them off the internet, so they're not exposed to attackers or somebody writing a script. Now, I did also take it to the next level because I was like, why don't we, and people always say there's, running jokes, you should never create pew pew maps in cybersecurity because, they're typically those maps you see on the antivirus vendors where they show, oh, there's a new cyber attack coming from like Russia, and it shows the little, like the laser, uh, kind of line going over, to hit the US, right? So we know that's a lot of smoke and mirrors going on, but I thought in this case I wanted to visualize it, so I'm going to use ChatGPT to go ahead and create this little world map and say, hey, we have this PLC somewhere in the middle of the United States. It's getting hit from all these locations over the world. Just visualize it for me. That's kind of cool. Again, it's just something I find interesting. It took a couple minutes to write with ChatGPT. I also then thought, like, well, what if we did this for all of those PLCs, those 50 that are exposed? And then you could start to see, maybe identify attackers that were targeting those PLCs. Yeah, you could. But then I also realized, again, those PLCs are connected to processes on the other end and don't want to impact those processes, especially if there's this idea of having some type of impact on safety, whether it's personal safety or the environment. So I thought, we better not. So that was as far as the research there and when, as far as like this kind of awareness exercise. And that's why we're just using the slides even to walk through this. I'm not replicating it. But again, it's another sample, one of those things where we can think of, hey, it would be great if I had a tool to do this. Even if it's just for research purposes, maybe just of things of we find interesting. Maybe nobody else finds this interesting. I find it absolutely fascinating because it's kind of like having a honeypot on the internet in a way, except I didn't have to host it. So one thing I wanted to point out is as we're building scripts, and you can see on the left-hand side, you can just come up with the idea for a tool and say, hey, I needed to do this, and I need to do it this, and I needed to do this, and I need to just put it in one big blob. And sometimes that actually works. But a lot of the times it doesn't. But if you take the same text, right, each of those sentences, and just build off of it one at a time, that typically tends to be much more effective for ChatGPT. So again, don't give it one big blob. Give it step by step. And that can typically be much more effective. Takes probably 10% longer, maybe 20% longer, but if the left-hand side fails, let's say 70% of the time, you're still ahead of the game by doing it little by little, right? Just to make sure. On the right-hand side, and this is the prompts that you can see, I used actually to create a really simple Modbus honeypot to run on just a Windows system inside your OT environment. It's very simple, but honeypots don't have to be complicated either. You just want to know if somebody is in the environment, maybe trying to connect to Modbus assets. It's not going to fool a state adversary into thinking, oh, that's a true Modbus, like a PLC at first. But it will catch the attackers that, as they're just getting in the environments and if they're scanning for things like Modbus. And so we can walk through this example where again, we're going to have it, hey, I want a Python script that runs on TCP 502. And you can put it on like a Windows or a Linux host and make it even look more like a PLC by using the local firewall to block other incoming ports, only allow it to expose 502. You could definitely do that to look more realistic. And then you say, okay, tell me anytime somebody pings this machine. Because we don't go around pinging, just randomly pinging systems and OT networks. So if you're seeing a ping request, maybe or maybe not, it indicates there could be an attacker in the environment. Now, a lot of attackers also probably aren't pinging things in OT networks. Sometimes they do, sometimes they don't. So also tell me, hey, if somebody tries to touch the Modbus port, they send a SYN packet. And then we send a SYN-ACK back, but we never get that final step of the three-way handshake to close out the session. More than likely, that's actually a port scan. So yeah, alert me that there was a port scan and tell me the IP address that it came from. Right? That's a great way to see if somebody's in the environment. Again, they're not always port scanning, but sometimes they do. And how often do you have legitimate people, operators, and technicians in an OT environment doing port scans? You shouldn't. So if you see potential port scan activity, sure, it could be a busted connection, but more than likely, yeah, it's a port scan. And yeah, it could be a technician that just found how wonderful Nmap is and they're using it, which they shouldn't be, but maybe it's an attacker. And he's kind of build. ICMP, maybe it's an attacker, probably not. Port scan activity could be an attacker. The other one, and here's a screenshot that you can see of what it, just on screen. It says, hey, we're getting pinged, and oh, there's a possible port scan, right? These are all things that bear investigating. Ping, and then we see a possible port scan. So I definitely would be looking at 10.2.1.226 in this instance to understand what's going on, right? What type of asset this is. Oh, it's an engineering workstation. Yeah, some guy just was using Nmap and or someone was pinging and doing port scans that she shouldn't have been. So we can have that conversation with them. But then we can add even additional levels to make it more realistic. We could even make it interactive. So what if somebody connects to Modbus on that Honeypot? What are we going to do? I don't want it just to take the connection and not do anything. That doesn't look realistic. So in this case, we're also kind of playing with with the attackers because somebody's connecting to the PLC over Modbus. At this point, it's not going to more than likely be a legitimate team member. It's going to be an attacker. So we're going to say if you're going to connect to Modbus and you're going to start to pull values, we're going to give you a list of values. I know this is kind of ugly, but you can see in this case, this is where it shows it, and it's recording all the Modbus activity to the log and to the screen. So you can see somebody connects to read values from what they think is a PLC running Modbus. And so we're going to send them 10 values. You see 0, 1, 1, 1, 0, 1, 0, 1, 1, 0. These are coils. That's where we store either zeros or one. It's just binary data. You can also see they're trying to read 10 different registers, right? So you can see, oh, there's higher values, and these are not just zeros and ones. So we're going to throw that data at them. And this is just random data that we're sending them. So that way, if they were to read those same values again, they would get different numbers. And then they would be like, what the heck is going on? And then they might realize we're playing with them. And then at that point, if we're watching the Honeypot, the jig is up. We know they're in the environment. And here you can even see where the attackers go to change values. So they're actually issuing a write command. So they see those values and they're making a change. And then we let them know, yes, your change was successful. If they go back to look at it, it'll probably be a random value. So we're screwing with them at that point. And sure, you can make it more interactive and make it look more real, but again, it doesn't have to be. At this point, if we're already going through this process, again, that's not a technician, trying to manipulate the PLC. This is an attacker in the environment. We know they're there. We can find them. We can get them off the network and hopefully prevent them from ever coming back. The Honeypot did his job. You don't have to spend 10, 20, 30, 40, 50 US dollars to buy a OT Honeypot. That's my approach, at least. So the last part of this conversation is going back to kind of the heart of the presentation or the video title. But this idea of what about using it for other different types of offensive tools? So, of course, we're approaching it from a pen test perspective or an attacker perspective. And by doing so, it makes us better defenders, right? And part of this video is to understand, again, the attackers are doing this. They're already doing this. They've been doing this. Like normal, we're behind the curve. So this is MITRE ATT&CK for ICS. So you might have come across MITRE ATT&CK for enterprises in IT. There's actually one specifically created for ICS. as well. And they talk about the different tactics, the techniques, and the procedures. It explains how attackers break into control system environments and what do they do once they're inside the environment. You see things like, yeah, they use default credentials, or, oh, like we talked about earlier, they upload malicious firmware to control systems. That's one of the reasons why we wanted to understand what operational mode a controller is in. Is it in run mode? That would prevent somebody almost always from uploading malicious firmware. Right? That's why we created that web page initially as part of my thesis research. So people can monitor, are their controllers in run mode or not? If they're not, you need to go over and get it back in run mode if it's not having maintenance done. Right? So that gives you an idea. If you want to learn more about how attackers get into OT and what they do, definitely check out MITRE ATT&CK for ICS. But you can also take all that information and start to look at how can we use this to create attack tools or pen test tools. Now, I use, and the PLC that we were scanning earlier is a Click PLC. It comes from Automation Direct, at least they're the reseller in the United States or North America. And so when you have a controller, a PLC that you want to connect to and you want to make programming changes, you would use the programming software that comes with it. In this case, it's called the Click programming software. But this is where I had this Click PLC, and I'm like, man, I have to determine remotely, right, without logging in, right, is it in run mode or not? So I get the PLC set up, I install the software. I am running Wireshark in the background because I want to see the communication going between the two. And you can see I double click the option to connect to PLC, and let's see what happens. And the first thing that comes back, it says, oh, this is what the screen looks like. I'm not asked for a username or password, but it says, hey, here's the PLC name, here's the IP address subnet mask, here's the part number, here's the firmware version of the asset, which we would use again to find out are there vulnerabilities on this asset or not. And then you can see the mode, the operational mode that I was after. Is it in run mode or not? I'm like, oh my gosh, right? Winner, winner, chicken dinner. Status is good, so it's up and running. It has good code that's running without any issue, and there's the MAC address. I'm like, great. I saw run mode, and I was like, I'm done. I went back to Wireshark that I was running in the background, and I saw when you ran the Click programming app and double click connect to the PLC, what it does is it sends out this broadcast over UDP to port 25425. And basically it's saying, hey, if you're a Click PLC out there, let me know. It repeats it 3 times, which is why you see more than the initial request and response. But it sends out, that request, say, hey, if you're a Click PLC out there, let me know. And then if there's a Click PLC out there like we have here at 192.168.100.200, it responds back. Like, awesome. So if anything, this is a way that we can find other Click PLCs in the environment. Now this is what it looks like in Wireshark when the data in the packet, where you not only send but also receive responses, so you can understand things like, oh, is it in run mode or not? Here, the very initial kind of like the header of the packet, or the data in the packet, I should say, is, you can see it translates to ASCII for KOP, which is the acronym for the German name, which I'm not going to try to pronounce, for ladder logic. And ladder logic is the most common programming language we have for PLCs or controllers today. So I can say, hey, take this payload, this data payload, and just broadcast it out on the network. So I can emulate that whole discovery process myself in Python. I can even say, hey, make it come from port 2770, because that's what the Click PLC software uses. You can actually change it if you want. It doesn't matter. I found out playing with it. But you can see, I'm going to send out this packet as a broadcast, UDP broadcast, and on 25425, which is the port that the PLCs are listening on. And when I get responses, let me know which IP addresses are out there. And so I can run that tool. In this case, you can see also I'm running from a Windows machine that has a ton of network connections, mostly because of things like VMware and right there's Wi-Fi connections and there's physical Ethernet connections and the list just goes on and on. So the first thing it says is, hey, what connection do you want me to send out this broadcast? Okay, awesome. I'm going to send this broadcast out. Interface number one that you selected. And then you can see we got a response back. It says, hey, there's a PLC at 192.168.100.200. And if there were multiple click PLCs out there, we would see all their IP addresses as well. Really cool. So now, I mean, from a defensive standpoint, that's cool, but also from kind of a pen testing or attack perspective, right? You can see how you could use ChatGPT to create this type of discovery or a enumeration or almost like a reconnaissance tool. I went back to the screen though and I said, okay, that's cool. Right? I can find the IP addresses. I don't need the Click PLC programming software. Well, what else is there, right? I can get the IP address. Well, we already did that. PLC name, okay, could be interesting. There you just see, I could just put in generic ABC123. That was when I was trying to map out the data packet. The part number, like, okay, kind of interesting. Firmware version, be very interesting. Or again, whole point of my thesis was, is it in run mode or not? So I could find in the Wireshark, in the data packet, in the payload itself, what represents whether it's in run mode or not. Again, I don't care about maybe it has 10 different values. I just want to see the one for, is it in run mode? So I can say when it's run mode or not. There's another option at the bottom you can see for the line for blink, run, and the error LEDs that are on the front of the PLC. The idea is if, let's say you're a technician and you go into a cabinet and there's 10 click PLCs and you want to you want to do an upgrade to one, and so you're going to physically connect to it with a cable. But you don't know which of the 10, right? There's nobody labeled them. You don't know which one's which. What you can do is you can click that button for blinking the lights, so that way if you're standing in the cabinet, you know, okay, that's the one. So we can take that payload just like we did earlier, right? We can just create this little Python script to send out that same response, but not using the graphical interface that sits there, and those lights will blink for like 2 or 3 seconds, enough for you to realize, oh, yep, there it is. Again, it's in this case, it's just us creating a Python script, but we're making changes, right? We're manipulating that controller, right? We're telling it to do something, and it's doing it. Do we have full control over the controller yet? No, of course not. But again, it's a step in that direction, right? Because again, we're reaching out, we're telling it to do something, and it's doing exactly what we're telling it to do. So we can start to think of different ways, okay, to take it to the next level. There's even an option if you click that edit button that it brings up the screen and says it allows you to change the IP address without being asked for credentials. Now they do a little process, so I can't get this to work 100% right with the Python script, and I just haven't spent a lot of time with it. But I can get it to work like 50, 60, 70% of the time, where you can change the IP address, which might or might not impact the process that PLC controls. The process will probably still run, but if a technician tries to connect to that IP address over the wire, there, of course, that IP address is no longer there. Or what if you have a different asset like an HMI that's controlling that PLC that needs that connectivity? It expects that PLC to be at that IP address, and now all of a sudden it's at a completely different IP address. You've lost control over that asset, at least remote control over that asset. And there, by extension, the process that it controls. So that's not good either. The last part we're going to talk about, and this is where you start to see, attackers particularly being able to manipulate controllers Because, and I always use a common example, and this really came into play with Frosty Goop, which was announced by Dragos at this point, probably 2 months ago. And this is where the Russian state created very simple malware. Basically, we're creating it here, and I do a demo later separately where we recreate the entire, this quote unquote state adversary, this APT tool that's actually very simple and very easy to recreate in 15 minutes or less in ChatGPT. But the whole point is that the Russian state used it to turn off the heating in 600 apartment buildings. Not 600 apartments, 600 apartment buildings in the Ukraine with sub-zero temperatures. So think of all the people that were impacted. And the heating was off for 2 days. That's 2 days. Think 48 hours. At least one, if not 2 nights. Sub-zero temperatures outside. I mean, there were obviously, people had to be impacted, right? Getting sick, potentially dying. Because a very simple tool. I always think of controllers, PLCs, like thermostats. And thermostats are PLCs for all intents and purposes. Right? It has a little CPU, it has memory, it has logic that's stuck in a loop. What sits and it checks. What's the temperature in the room? Right? And we have a set point. We said, hey, we want it to be 72 degrees. Thermostats always continually bringing in input from to determine the temperature from a sensor. And then all of a sudden, ooh, it's 73 degrees. We need to turn on the air conditioner. It sends a signal, an electrical signal to the air conditioning unit to turn on. The thermostat's still there checking the temperature. And when it gets back to 72, it realizes, ooh, okay, we're going to send another signal to turn off the air conditioning unit. That's how control systems work. So what if you can manipulate things like the temperature, that set point that was in the PLC? Or what if you could turn the thermostat just off? So those are some of the things. Think of the things that we can start to control and manipulate. By when we talked about those coils and registers earlier. So when you have a control system asset running Modbus is basically has its own little database, kind of like SNMP, or you can think of it as maybe an Excel spreadsheet or CSV file or a SQL database. But it has those coils, again, that store zeros and ones. Maybe, again, one is on, zero is off. Right? Turn off the thermostat by setting it to zero. Like, very simple example, but let's go with it. Or if I look at the registers and I see a register that has a value of 72, that could be the set point for the temperature. Well, what if we can change those? Because Modbus is an unauthenticated protocol. It doesn't ask you for a username and password or just a password to be able to read those values and make changes. It just allows you to read those values and make changes. Where attackers slow down is they don't know what's on the other side. So they have to take the time to figure out, what does that controller actually control? Right? What's the process that it's controlling? That's what slows down attackers. It's not getting to the PLC, it's figuring out what the PLC does once they get to it. But in this case, we're just going to say, hey, write a tool that's going to allow me to connect to a PLC over Modbus, and it's going to allow me to read and make updates. So in this case, you can see I'm telling it, connect to this PLC at 192.168.100.200, starting at register number 5. Right? I'm going to update that to be a value of 1616. So it was 0. I'm going to change it to be 1616. So I'm going to take register number 5 and change it to be 1616. Again, if we don't know what the process is or what the controller is doing, that could break something, or it does nothing, it could blow something up, or it does nothing, more than likely, probably does nothing. And then you can see all the other registers have a value of 0 as well. If you want to make sure that, oh, did we really actually make the change? Yeah, well, I'll just go ahead and rerun it again. I'll go ahead and do an update to the first register. I'll change that to 1010. Still see, though, that register 5 is set to 1616. I made that change. Again, what if I just change it to maybe it's 72 and that's the temperature, and I change that to 32? Would the temperature, would the thermometer work at all? Would it turn the heater on or not? Just depends on, right, the programming of that thermostat. And we don't know, more than likely, what's happening without further information. Again, Modbus and other industrial protocols are unauthenticated. There's literally zero security built into these protocols. So you can connect to these controllers and you can make changes to those registers and to those coils, to those values. And to wrap it up, right, I decided, well, I have all these pieces to do things like scan for click PLCs and flash the lights, right? Give me the name and list out all the other information like the firmware version, update the IP address, read, write coil. I could put all this together in just one. And I actually just started putting this menu together, and then I added in the functionality for scanning for click PLCs. And then I found out I didn't even have to give it the functionality for reading and writing coils and registers like 5 and 6 here. It automatically built the code in for me. That was another thing that I was like, oh, that's really cool. And then it's like, wow, for like especially the attackers, or this is where, script kiddies, right? Someone with no technical experience can use ChatGPT to create a fully functioning attack tool for control system networks. Again, that's the whole reason this video exists. They're already doing it. The attackers are already doing it. But we, as the defenders, as the cybersecurity professionals in ICS and OT and IT, we have to realize they're doing this. Because it does make it that much more difficult for us to defend our environments. Because there's more attackers with more tools out there, and they can be very effective. So what comes next? So for us as defenders, where do we go from here? For me, I'm going to be writing my own tools from a defensive standpoint, like the Honeypot, right? That's a great example of how we can use ChatGPT for good. But also, just understanding that the attackers are doing this as well, right? They're upping their game. We need to up our game as well. They're going to use ChatGPT or other GenAI to up their game. We need to do the same. We don't have a choice. We're always behind the attackers anyways. So we need to keep on that same path. For attackers, they're going to keep doing what they're doing. They're going to keep building tools. They're going to keep breaking into environments. They're going to be deploying ransomware to get money. They're going to, sometimes, if they're hacktivists, they want to take down the environment. If they're state adversaries, maybe they're getting your environment to steal information and put themselves in a position to then later impact the environment, like making things go boom or shutting down the environment at a critical time, right? Turning the power off in the middle of winter, turning the heating off in 600 apartment buildings in the middle of winter with sub-zero temperatures. Those are the types of people that we need to protect the world against in ICS and OT. And I mentioned Frosty Goop. Frosty Goop's a great example, right? The tool that the Russians used to turn off the heating for 2 days in those 600 apartment buildings in Ukraine. That's a perfect example. It's really exciting from the researcher perspective to look at, but then you put yourself, like, what if you were one of those people in those apartment buildings? That's a big part of the ICS OT cybersecurity equation. It's just not a system going down for ransomware. It's we lost power or we lost heating in our apartment building for 2 days when it was below zero outside. Yeah, really concerning. And this is just the beginning. So what comes next? A lot more. And it's only going to come faster and have higher impact. Right? It's not going to be 600 apartment buildings. It's going to be 6,000 or 600,000 homes. And it's not 2 days. It's 2 weeks or 2 months. It's coming. We have to be prepared as defenders. So hopefully this presentation will help highlight some of those concerns and how you can also use ChatGPT to, right, create your own tools for defense. And if you're a pen tester, sure, as offensive tools. And one last point just to make, right? Just remember that GenAI today is the worst it's ever going to be. It's only getting better and exponentially better every day. So again, it's great for us as defenders. It's great for the attackers though as well, which is not good for us. It's only going to get better, again, exponentially every day. So it's going to be a crazy wild ride, and we have to be prepared. So thank you again if you made it especially to the end, but don't forget I have the documented walkthrough on GitHub. And then if you want to reach out, you can find me at all these places, LinkedIn and YouTube and GitHub, etc. So thanks for the watch, and we'll see you in the next video.